Hello, I'm Sean Connolly, and this is Railway Conversations with Doc Frank.
Hello and welcome back to the show. My guest today is Sean Connolly. I had him on the show before in episodes 65 and 66. And Sean is a really good guy to talk to. He has built a nice lifestyle in Malaga in Spain, beautiful city. And he has become an expert on high-speed rail over the years. He has recently published a report, a massive 66-page report on recommendations for high-speed rail for the Australian market, because Sean is originally Australian and still very interested in what's happening in his area of expertise in our own country and in his birth country. Today we cover part 1. Part 2 will be next week. Make sure that you don't miss it. And the best way to do that is to subscribe to the show. And if you think a friend or coworker of yours could be interested in this as well, please recommend it to them. They will thank you. Enjoy. This podcast is not sponsored by third parties, which means uninterrupted listening to the episodes for you, and I hope you appreciate and enjoy that. If you want to support the show to keep it going, there are 2 ways you can do it. One is the typical request for podcast: subscribe and share with your friends. The other one is specific to the show and myself. I host a training portal with arguably the world's most comprehensive course offer on digital signaling technologies and everything to do with high capacity. Some of my trainings are one of a kind, which means unique in the world. For example, the high capacity signaling blueprint, the high capacity railway mindset training, or most recently, my course about digital signaling interoperability. All of those courses are online, so you can watch the lessons at times convenient for you and as often as you like. And there is an industry-leading Q&A support where I will answer your questions not just during your training, but at least for further 12 months after you completed your course. What you can do that would be really nice is checking out this training portal, which you find at docfranktraining.podia.com. That is docfranktraining.podia.com. And if you find that you or a coworker of you can benefit from any of those courses, I would be very happy to see you growing your knowledge, understanding, and confidence through any of my trainings. Thank you. But now, please do enjoy this episode. Sean, welcome back to the show.
Thanks very much for having me. As always, it's a great honor to be invited, so I'm quite happy to be here.
Thank you very much. I mean, for those who haven't seen or heard our previous episodes, we had a previous long chat about 2 hours, which I cut into 2 episodes of this podcast, previous episodes. I will have links in the show notes. And the reason why I wanted to have you back on the show is that something I think quite important happened. You published a report on LinkedIn. I'm not sure where else you published it, but I saw it on LinkedIn. It's quite a massive 66-page document, seems to be very well researched, very elaborate, has certainly taken a lot of time and effort. Why did you do that?
Well, for a number of reasons, I suppose. As we've spoken before, I'm very passionate about rail and especially passionate about high-speed rail, especially about Australia. As an Australian, I'm also probably one of the few people who, one of the few Australians who has some experience with high-speed rail. I've undertaken a number of studies across nearly 100 high-speed railways in operation. That's given me some deep insights into what works and what doesn't work with high-speed rail. So I suppose as an Australian railwayman overseas with some considerable experience in high-speed rail, I suppose it's almost my civic duty as an Australian to weigh in with my 2 cents worth. But the bottom line is, I really think I do have something very useful to add to the conversation that can actually help Australia and high-speed rail in Australia move forward in the most efficient and most cost-effective manner. So I suppose there's a number of reasons there, but they all combine together, and I bit it off. I was going to do this, I was going to do that, and it's sort of the more. It was one of those things that the more I got into it, the more things I found, and the deeper I went. So there's some real heavy work in that. It took me a good couple of months of 6 or 7 days a week, getting into it and doing the proper analysis and validations and research where necessary to make sure that it's a very robust operations plan. As I say in the document, it's not an exhaustive plan for high-speed rail in Australia, but it's certainly an exhaustive operational plan that can and maybe should be used to influence and shape the design and construction of the infrastructure. Let's get this thing around the right way. Yeah, let's not be driven by building a nice fancy railway that you can't then run a service across. And I think that was something that was maybe a little bit missing in the original 2013 report, and in other reports, that we really needed to start from the end and see or get a picture of what the service actually looks like in operation, so that we can work back from that and include the requirements and the design requirements in the original construction of the infrastructures that can then support those operational requirements, which is at the end of the day what we're doing here. We're not, as I say in the document, it's not an infrastructure construction project. It's the HSR project is a project to operate a high quality, high performing operational HSR service that meets the needs of the passengers or the users in the case of freight. So I think it's useful from that point of view that we start at the end, and we're very clear on on what we're delivering and who for and why we're delivering it, and we're not just going away and building infrastructure for the sake of building infrastructure.
Yeah. So a bit of back information for those who haven't seen or heard the previous episodes. You are based in Spain at the moment, but born and bred in Australia.
Correct. Yep.
But you do have no direct involvement at the moment in the Australian rail industry or what's happening over here, other than obviously a keen interest because, well, you are Australian. Obviously, you are interested in rail in Australia. One thing I wanted to emphasize, in case somebody didn't quite catch it, you were mentioning a database of nearly 100 high-speed rail projects. 100 was the number, people, not just like 10 or 20 or so, which would already be a lot. We're talking about nearly 100. So arguably, that may be the most comprehensive database for high-speed rail in the world. It's not just yours, but you participated in that, and you definitely have access to it. Obviously, many other people will have contributed to a massive body of work like this. But your recommendations and also this report we are talking about is based, obviously, on the experience, on the lessons learned from that database, from that comparison of high-speed rail projects, right?
Yeah, there's certain observations you can make as you go through, and we'll get onto it later. But you can draw certain conclusions as to what's successful, what's not so successful, what costs a lot of money, what keeps costs down. When you've got volume, if you like, of data, and you're a bit analytical as I am, you can sort of dig into that data and and draw some very, very, very insightful conclusions out of it. Yeah.
Yeah, I did something similar myself a few years back. I was contracted as a consultant to the Digital Systems program in Sydney, which is about the introduction of ETCS level 2 to Sydney. And the one of the tasks that I have was the installation of a lessons learned framework.
Mm-hmm.
So I looked at, well, all across the world for projects of similar nature than what they wanted to do in Sydney, not just ETCS projects, but also generally projects where the capacity of a railway in a city was to be increased. So CBTC
Sure.
projects were in
Mm-hmm.
there and so on. So what I found, the more you look at these, and the larger the number of projects you're looking at, you see the development of certain patterns. You see
Exactly.
certain things that repeat time and again, maybe in different combinations in different projects, but you can really identify some kind of ground rules. And we ended up with like a top 20 lessons to be learned that would be useful for Sydney. The project director at the time wanted to have a high level for executive use, like a top 20 list. He said, don't come to me with 200. I just want 20. Ideally,
Yeah.
just 10. And I said, with 10, you're really losing something important, but I think we can cap it at 20 and it will be pretty good. So,
Yeah.
and I assume, and mind you, I didn't have 100 projects. I had a lot, but I didn't have 100. What I suspected you would have done is that if you analyze enough projects, you find some common denominators for
Exactly.
success or missuccess, where you say, well,
Exactly.
that's a criteria. Certain
Exactly.
projects have done it this way, other projects
And
have
it
done it that
worked, and
way.
it worked well. And these other
Yes,
ones
it
that
worked.
didn't do that, and they were, very expensive or whatever it was, because of these factors that they or design decisions that they decided or that they didn't decide in the original instance. And yes, you can start to draw lines through the data and draw conclusions.
Yes, yes. So, okay, the report is about high-speed rail.
Mm-hmm.
But it's not just about high-speed passenger rail. You also integrated high-speed freight rail. Now,
Yeah.
this is something that is currently, I think, completely not investigated at all. I'm not aware that this was part of previous studies. I'm certainly not aware that this is part of the current work of the High-Speed Rail Authority. So is that just something where you thought, that's a good additional idea, or how did this come about?
It's not been analysed very lightly, or if at all, in any previous studies. However, I know that the High Speed Rail Authority, Tim Parker and Graham Nelmes, have thought about it. And I don't think that they may not have given it any great analysis, but I know it's on the radar. It is something that I think could work and would be useful, given that, well, the high level stat that I always quote is that less than 2% of containerized freight now goes between Sydney and Melbourne. 2% of the total freight task is just it's not going to do it for greenhouse gas emissions or accidents or safety. I've come up with a plan that allows both freight and passenger to operate over the same infrastructure, separated by time bands. Obviously, the demand works because the demand for passengers is basically just before, during the working day, and just after the working day, which leaves capacity on the network infrastructure to run a couple of high-speed freight trains at late nighttime times. If we use the right locomotives, and I've suggested a couple in the report, which are basically last mile or bi-mode or dual mode locomotives. We can fully integrate, and that's another important point that we can probably touch on later. We can integrate high-speed rail freight with both inland rail and the conventional rail freight networks. It adds capacity for rail freight. It adds much needed speed to certain niche markets, if you like, things like parcels or perishables. Never mind, an overnight containerized rail freight service that will actually service Sydney. And this was something that I thought was a little strange, that inland rail, which is being built at the moment, is going to go from Melbourne to Brisbane through the interior and not actually call it Sydney, which is Australia's biggest rail freight market. So if Australia's serious about shifting to rail and getting more freight off polluting trucks and roads and onto a much more environmentally friendly rail, it seemed to me very strange that it wouldn't go through the biggest market, which is Sydney. There was something like 20 million tonnes of containerised rail freight that went between Sydney and Melbourne. The data was a couple of years old, 2019 or something like that. But of that 20 million tonnes of containerised rail freight between Sydney and Melbourne, only 2% goes on rail, which is just doesn't seem right to me, given that we've got greenhouse gas emissions targets to meet. There's a lot of congested roads, the Hume Highway, the Bruce Highway, the M1 motorway, very congested roads, highly polluting trucks. High-speed rail freight just made sense to me, and especially if it could be integrated seamlessly with inland rail and the conventional rail freight networks to meet a number of, if you like, problems or issues that Australia's currently got with a lack of freight being moved more efficiently by rail. Yeah.
Well, inland rail was specifically designed to cut around Sydney. That was the whole purpose of that thing, because all the freight traffic between Melbourne and Brisbane was impeded by having to go through Sydney, and Sydney is extremely congested. Freight trains in many instances have to share the suburban network with all stopping suburban trains. So it's not really.
Yeah, I understand all that.
It's overcrowded, and that's the reason. Without talking too much about inland rail or shifting the attention there, it is what it is for a reason. Yeah, so it was meant to be a shortcut going directly between Melbourne and Brisbane.
To miss out the biggest market.
That doesn't mean though that the modal share of freight rail between Melbourne and Sydney is satisfactory. So if you say it's only 2%, that's ridiculously small, and certainly something that deserves improving. Inland rail will not improve this, full stop, because it's just not there for that purpose. But a high-speed rail connection, freight rail connection, could do that and could at least improve the capacity and also create a connectivity that has advantages over road traffic, because it would just be faster. Yeah?
Well, exactly. It's new infrastructure, so it avoids a lot of that current congestion. New infrastructure, new capacity. The paths can be found late at night. It seems to make sense on a lot of counts. Yeah.
Yes. Well, in the rail industry, there is a bit of a philosophical almost difference between two approaches. One approach saying high-speed passenger trains require a certain infrastructure that's ideally dedicated for high-speed passenger rail. So
Correct.
the axle loads normally don't have to be as high as for freight trains, and but it needs to be built for higher speeds.
Correct.
And so that's one of the philosophies. The other philosophy is, well, we have tracks that are suitable for high-speed passenger traffic. If we build those tracks a little bit more robust for higher axle loads, we could also use some of the capacity of that railway line, for instance, during the night when we don't run passenger services, for freight trains. In Germany, for example, that's the model there. And as a consequence, the track design, the track construction between those two approaches is quite different. And also quite different regarding cost, cost of operation and maintenance and stuff like that.
Yeah, no, and I make note of all of these things in the report. I suggest that we limit the axle loads to 19 or 20 tons for that reason. I do also mention that, yes, that will have some design impacts upon rail and steel density. It'll have some impacts upon the ballast required, et cetera, et cetera. So, yes, there is a slight trade-off there. I think it's a trade-off that's certainly that's certainly got some merit, and I think it's certainly worth investigating, especially given that we've got, everybody wants to get more freight off roads and onto rail, but this is how you do it. There's this goodwill, if you like, to get freight off roads and onto rail. But for the first time, we've now got some sort of plan of actually how we actually do that, and that those benefits can then materialize. Yeah.
Well, I think what I would expect is that for high-speed rail freight, you need a specific operational plan in the same way or in a similar way that you need a specific operational plan for high-speed passenger rail.
Sure.
So
sure.
What I mean by that is the freight or those freight trains have to come from somewhere. So they basically have their excess spurs going onto
ingress
the
and egress
track.
Ingress and egress. Yeah. Yep.
Exactly. And these touch points with other parts of the freight network, say to intermodal terminals, to ports, something like that, they need to be managed quite carefully because, as you said, there's a limitation of axle loads on the high speed line. So you can't just take any odd freight train that's carrying like heavy bike stuff and say, well, we just take the freeway up to Sydney and that's beautiful. And then afterwards, the next morning, you can't run your passenger trains because your track is
blocked up with freight trains. Yeah, and I make specific mention of the differential speed issue. That's why I detail quite extensively the protocols for high-speed rail freight on the high-speed infrastructure. There are ingress and egress points into the Sydney rail freight network that serve the intermodal terminals that would be very important in high-speed rail freight. Those intermodal terminals, I think, are mostly around, off the top of my head, Chullora, Strathfield, where the Sydney rail freight network would be most logical to have a spur off onto the high speed rail infrastructure. I'm quite specific with the characteristics of the locomotives that would be required for high speed rail freight, particularly in regards to the speed, so that they would get off the high speed infrastructure in advance of starting operational passenger service the following morning. I also mention about well, for example, signalling. So, if the passenger trains are ETCS level 2, baseline 3 or 4 or whatever, that the freight trains must be signalled the same, and they'd be controlled from the same operational control centre. Passenger trains would get priority, etc., 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 etc. Again, it opens up a couple of things. Like we mentioned, the density of the rail. There's also things to consider in regards to the loading gauge, or what do they call it? The kinematic envelope of the
Yes.
of the trains, particularly when we're going through tunnels. And there'll be a lot of don't forget, there'll be an awful lot of tunnels going north from Sydney through the Central Coast up to Newcastle. So, these things all must be taken into account, and I mention them in the report. Yeah.
Yes. And the locomotives most likely would have to be electrified. I don't really think you would.
I suggest dual mode. Because obviously, to get from the intermodal terminals through the ingress and egress, that's not electrified. So that will have to be diesel or battery or some sort of bi-mode. And I suggest a couple of locomotives there. Just for the sake of the example in the report, I mention the lovely new Siemens Vectron bi-mode, which is a fantastic loco, or probably the most popular locomotive in the world for freight at the moment is the Bombardier, or in the Alstom Tracks do a last mile train as well. That's dual mode electric diesel. So that would have to be the characteristics of the locomotive that would haul the freight. However, there's a double advantage there. By using a dual mode or a last mile loco, that means that locomotive can also be used during the day, or for partial routes between electrified and non-electrified routes. In other words, between high-speed rail infrastructure destinations and other destinations, just by switching over when it moves off the electrified high-speed rail infrastructure onto a non-electrified infrastructure. It allows operation over both types of networks, which allows huge integration between for these freight trains and additional destinations that can be served if you use a dual mode or a last mile locomotive to haul the freight. Yeah? So that's what gives us then the additional advantage of integrating a much wider rail freight network that includes high-speed infrastructure, conventional rail freight networks, and inland rail. And given that there won't be any freight during the day when the high-speed rail infrastructure is required for passengers, during the day, these trains can be operating over the conventional networks, or inland rail, if you like, when they're not required or not able to access the high-speed infrastructure during the day. They can be operational and in use during the day over the conventional or IR networks. So there's a number of advantages there if you use the right rolling stock.
I think this opens up the discussion around another difference in philosophies, let me say, which is a dedicated network for high speed versus an open access network for everybody and everything. And the risk that I see, there's a case for that in Sydney, where Sydney Metro was introduced as a complete new mode of transport. Well, it's rail in the same way it's rail on the suburban network, but it's a completely separate rail network with no interconnectivity, no track interconnectivity to the suburban network.
Okay.
And that has a lot of advantages, because you can use innovations on the metro that you couldn't use on
driverless
the
GOA 4, etc., etc., etc. Yeah,
exactly all these kind of things. So it's a completely different operation. Now, in a similar way, I think that a lot of high-speed services around the world are dedicated services as well. I don't think the Japanese run freight trains on the Shinkansen lines.
No, of course not. Because well, I could go on and on and on about the Japanese, but no, the answer is no. I think
Yeah.
I think the point that to remember here is that yes, I am suggesting that it would be completely dedicated high speed infrastructure. It will be separated, and freight trains will never share the infrastructure with passenger trains, for the specific reason that passenger trains have this differential speed issue with slower freight trains. It will be separated by the use of the access window. In other words, freight trains will never share the infrastructure with passenger trains, and that will be bounded by time. Yeah. So if your last passenger train pulls out of Sydney at 10 o'clock in the evening, which completes the day's passenger service, that's when the trains can run on the proviso that the freight trains are off the network before your 5:30 a.m. train pulls out of Sydney the following morning. Yeah.
Yeah. Well before probably. Probably. Yeah. I'm just wondering how this would be managed. Like who? I'm not sure whether that's in your report or whether you put any thought on that. Who should actually operate the high-speed infrastructure, including regulation of access, making sure that the rolling stock running on the high-speed line is actually fit for purpose, like having the right type of locomotives with the right speeds, with the right wagons, with the right kinematic envelope. So it couldn't be, for example, inland rail trains, because the trains on inland rail are all designed to be
double stacking.
Bigger, double stacking container.
Double stacking won't go through the tunnels. We'll pull the overhead lines down. No.
Yes. So that's there's definitely a restriction where it needs to be monitored. It needs to be managed.
There needs to be an authority, an infrastructure manager, and the infrastructure. Yeah. You know, there's always an infrastructure manager on whatever railways. So sometimes the infrastructure manager is the operator. Sometimes the infrastructure manager is a government authority. I'm happy for either of those models as long as it exists. Again, yes, it must exist. There's a number of options, and as a part of the overall development of the network and the services, an infrastructure manager must be created or appointed, or one way or another, it must exist, and the relevant authority might not be the infrastructure manager in all cases. For example, in England, if I want to run a new type of train between London and York, I need to get approval for my train from, for example, the Office of Road and Regulation, the Office of Road and Rail Regulation, which is not the infrastructure manager. The infrastructure manager is Network Rail. I might need to get an approval from Network Rail as well, but it's just it's another level of regulation, if you like, or approval that needs to be in place and taken care of.
Yeah. In your report, in the headline title page, you're using two different acronyms for freight. You're using HSRF, which stands for high speed rail freight. And you're also using FFR, which stands for fast freight rail.
Yeah.
What's the differentiation there?
Completely interchangeable. I know for example, in Europe, we generally use the acronym HSRF. I think in Australia, it's previously been referred to as FFR. So in order to avoid any confusion, I've included both. It's the same thing.
Okay, so it's the same thing.
Yeah.
So it's not like different speeds for different applications or anything.
No, it's just that in Europe we use a certain term, and I think in Australia it's been mentioned with a different term. Yeah.
Yeah. How critical do you think that idea of high-speed rail freight is for making the business case for high-speed viable in Australia?
It will contribute. It will help. It's obviously it's passengers that are going to be the make or break, and particularly high value, high quality business class passengers between Sydney and Melbourne. That is the make or break for high speed rail in Australia. However, every little helps, and if we can get some additional revenue late at night when the infrastructure is not otherwise being used, what we used to call in accountancy sweating the asset. Yeah, so it helps to amortize the huge original cost. We can get a little bit of extra revenue. We can do some good things around sustainability and greenhouse gas emissions and environmental reasons. We can do some good stuff around accidents and reducing accidents between heavy goods vehicles and private cars on very congested freeways. So there are benefits, but rail freight won't be the make or break. It'll be the high quality, high value business passengers between Sydney and Melbourne or Sydney and Brisbane that are the make or break for high speed rail in Australia.
Why the business travelers? I know, but maybe not all listeners know why that focus on the guys in suits or the ladies in suits, but well, in most cases probably
because they pay, or they don't pay. Their company pays. They pay, right? They pay for a business class seat. They're not. Their elasticity of their demand is much less, shall we say? Because if I'm personally, I want to go up to Brisbane for a holiday. I'm going to search for the cheapest price, and the cheapest price is not making me as the operator much money. However, if I have to go from Melbourne to Sydney for business, I have to go. Yeah, if I've got a meeting or a conference, I have to go. And if I'm going, my company's paying, and my company's going to buy me a business class ticket. Yeah. So that I can maybe work while I'm on the way up. And the business class ticket's going to cost you a bit more. And there's a higher profit margin in a business class ticket than Sean Connolly personal that's going up to Brisbane for a holiday.
Yeah. The frequency of travel probably also plays a role, right? Because the last thing you wanted to achieve with your new high-speed rail is to create another Indian Pacific, which is more or less a tourist railway, just at higher speed, right?
Yeah, correct. It's obviously the distance is exponentially more across the Indian Pacific, but whilst there certainly is a customer segment for tourists and private travel, most definitely. By far and away the largest percentage of the profits of the revenue and profits of the high speed passenger rail service is going to come from business travellers. Business travellers Sydney, Melbourne, business travellers Sydney, Brisbane.
I'm still wondering about the format, how you publish the content, like really putting months and months of effort in to write a comprehensive 66-page document and then basically drop it all in one go. You can download it for free. I would say some consultancies producing a piece of work like this would probably have charged millions of dollars. Provided that there was a customer that commissioned that kind of work. And others, just content creators that doing it for the fun of it, like myself, for example, I may have chosen to basically have this in little chunks and have content for, 200 posts on LinkedIn or something like that. So what made you writing up a piece of work that could actually be used as it is almost as a Bible or a reference book for high speed?
Well, that would please me. Free. That would please me enormously if it's used as a Bible or as a reference. If if somebody's quoting Sean Connolly, I'll be honest with you, that's a huge boost to my ego. Yeah. Okay. However, the simple fact of the matter was I didn't have a client, so yeah. I partly I was sort of hoping that it may generate me some business. That would be nice. That would definitely be very nice. But like I say, it was generally, if you want to call it, it was a passion project. And like I say, the more I bit off, the bigger it became. It was one of those things that just sort of grew and grew and grew and grew. I thought, okay, yeah I'll do half a dozen pages here, and that'll be nice, or whatever else. And like I say, the more I got into it, the more it required. And from a personal point of view, I am a rail professional, and I want to be professional, so it wasn't do one of these Johnny amateur jobs and leave huge gaps that you could basically drive a train through. I wanted it to be robust, and I wanted it to be something of value that would stand up to scrutiny and could be perhaps considered as as a useful document, or a useful set of guidelines, or a useful plan to then shape the design or construction. One of the things that I did do, the deeper I got into it, I kept on finding, shall we call them, anomalies, where they just weren't sensible. Yeah, and you couldn't operate a service like that. So that obviously it makes no sense to build infrastructure that can't support the service. And I think we've seen that in certain places. We may not go exactly to England, but building infrastructure for the sake of having a nice set of shiny infrastructure that you can't operate a decent service over, it doesn't make sense, especially if you're going to spend $114 billion or whatever the equivalent 2024 value of that is. Yeah.
One of the quotes from I'm not sure whether it was from the report or from a post that you did to publish the report. One of your quotes was, high-speed rail is not an infrastructure construction project.
Correct.
What do you mean by that?
Well, it's not. It might not be a popular view, but it is not an infrastructure construction project. It is a project to operate a high-speed rail service efficiently, cost-effectively, high levels of customer satisfaction. That, of course, does have some very serious dependencies on having the right fit for purpose and appropriate infrastructure to support that. But it must be driven by the service. It's not to be driven by having nice, bright, shiny, new infrastructure. The infrastructure serves the real objective, which is to operate a quality service.
So you start with the end in mind. You're not just building a piece of railway, which would be that infrastructure construction. Then you say, oh, what do we do with it? Okay, well, the part in New South Wales will be handed over to Transport for New South Wales. The part in Victoria will be thrown over the fence to the Department of Transport in Melbourne, and then they can sort out who's going to operate. And then you get another state border in there, which will eventually lead probably to some deviations on both sides of the border, and something that's not fully integrated with different service patterns on both sides and all kinds of stuff. So what I understand you say is you need to think about ahead. What does the service model for an integrated high-speed service may look like?
Exactly.
Who will be responsible for that? And then, oh, by the way, we need to build some infrastructure which is dedicated for that purpose. Exactly. We need to procure some rolling stock.
And the infrastructure, in order to support that service that we want to operate, must have these characteristics: A, B, C, D. and that also helps us with, the key question, as always, is the design speed. What design speed do we need to build for? You can't just sit around in a room with Lord Adonis and say, "Oh, let's do it at 400 kilometers an hour." Yeah, and then go ahead with that. Who's asking for 400 kilometers an hour? Nobody. But we've already designed the railway, and it's going to cost us an absolute fortune. But it's not fit for purpose. Yeah, it's not fit for purpose for the service that we want to operate. So we go, as you said, we start at the end. What are we trying to do here? We're trying to operate a high quality, high speed rail service, whether that's freight or passenger. Okay, they'll have different that will mandate some different requirements in our original system requirements document. But we look at it from meeting the end goal of the project. The end goal of the project is to operate a service, not to have nice, bright, shiny new infrastructure constructed. The goal of the HSR project is to operate a high quality, high customer satisfaction, high speed rail service. Yeah. So we start from there.
Hi, it's Doc Frank again. Hope you enjoyed today's first part of this conversation. Next week, Thursday, will be part 2. Make sure you don't miss it by subscribing to the show. See you later. Hi, this is Doc Frank again. I need to tell you about my brand new online ETCS training. It's the online version of the well-proven ETCS Kickstarter live training that has helped more than 200 railway professionals in Australia and New Zealand, regardless of their prior knowledge of signaling. So that really means you can learn the fundamentals of the European train control system, even if you didn't have any signaling knowledge before the training. How good is that? There's an online study group for networking during the training, and I also provide an industry-leading support of questions and answers, not just during your training, but also for a guaranteed minimum of 12 months after the training. Sign up now at docfranktraining.podia.com/ETCS. That's docfranktraining.podia.com/ETCS. Hi, it's Doc Frank again. I hope you liked today's episode. I like to keep it as simple as possible, so I only have one single request for you. If you like this podcast, please tell your friends and colleagues about it. That's all I want, because that's a service that I'm providing to the industry, and I would like as many people as possible to listen to this podcast and learn something from it. So please share. And until next time, keep it simple and bye for now. Thank you for listening.